6-month journey. They would then remain on the Martian surface for a year and a half. This would give the team time to explore a wide area and conduct detailed research about the planet. Then, as the Earth return window opens, the crew would launch from Mars for the 6-month trip home. Zubrin was convinced that a simplified, more robust and cost-effective mission could be designed using these principles. Along with several like-minded colleagues, Zubrin decided to ask management at Martin to allow them to design alternative Mars missions.
The management approved that, and we formed a team. It was known as the Scenario Development Team, of just 12 people from the whole very large Martin company.
One team member, whose thinking was closely aligned with Zubrin's, was David Baker.
I went off to my office and said, all right, how would I do a Mars mission if I had to pay for it and I had to go on the ride? And I said, well, it's going to be simple. There's going to be no on-orbit assembly. I really tried to take everything out of the mission that didn't absolutely need to be there.
While the rest of the team focused on longer-term, more traditional mission plans that required on-orbit assembly, Zubrin and Baker decided to collaborate on a mission that could be done near-term.
We decided to do Mars the way Lewis and Clark did America. Okay? Use local resources, travel light, live off the land.
Zubrin and Baker were convinced that a Mars mission could be launched directly from the ground. The other team members felt this was impossible, that the weight of the rocket fuel required for a round trip to Mars was so enormous it would render the launch ship impossibly heavy. To solve this problem, Zubrin was exploring a radical idea that had been kicked around the aerospace industry since the 1970s. The idea was to produce a methane-oxygen rocket fuel directly from the Martian atmosphere. It was a relatively simple and robust chemical engineering procedure that was done commonly in the 1800s, the era of the gaslight. If the idea worked, astronauts could land a relatively light ship with empty tanks. They wouldn't have to ship all the fuel with them for their return trip. This would radically lower their size and weight. The only problem was methane-oxygen fuel requires a hydrogen component. Hydrogen exists on Mars in the form of H2O, but water may be difficult or impossible to extract from the Martian environment.
Really, the hydrogen was only 5% of the total weight of the methane-oxygen propellant being manufactured. So if you just say, okay, we won't be pure, we won't get all of the propellant from Mars, we'll just get 95% of the propellant from Mars. The other 5%, the hydrogen, we'll just bring from Earth.
Another fundamental resource that could be extracted from the Martian environment is oxygen. A second processing unit could separate oxygen molecules from the thin carbon dioxide atmosphere, providing breathable air for a Mars crew.
If used intelligently, the same resources that make Mars interesting are precisely what could make it attainable.
Baker and Zubrin had greatly reduced their mission mass, but they still found their ship was too heavy and would require 2 launches and assembly in space. Then Zubrin hit on an idea.
Well, one of the key events of the Mars Direct development was one morning Bob burst in my office and said, I've got it.
The idea that I finally hit on in 1989 was that we would split the mission up into 2 parts, and we'd send the return vehicle out first with its own return propellant plant. So the propellant would be made on Mars before the first astronauts ever left Earth.
With 2 separate direct-to-Mars launches, a human crew would have a fully fueled ship waiting for them on the surface of Mars before they ever left Earth. So Zubrin and Baker had come up with a plan that seemed to accomplish all of their goals. It was relatively inexpensive, development time was short, they could use existing technology, and it allowed for a long stay on the Martian surface. They dubbed their idea Mars Direct.
SSC disconnect enable on. 35. Let guys go. Hydraulics go.
Aboard an Ares rocket is the Earth Return Vehicle, or ERV. No one is aboard this ship. It will pave the way for the astronauts who, years later, will use the ERV to return to Earth.
1. And liftoff.
its second day, the ERV deploys a small nuclear power reactor. The reactor powers a chemical plant inside the ERV. The plant will produce the methane-oxygen rocket fuel for the launch home. Nearby, a second robotic rover is guided to a pre-picked landing site for the human crew. It places a radar transponder to help guide the astronauts in. The long journey to land a human being on Mars begins.
3 more. 3, 2, 1, engine start.
Carrying the most skillfully assembled flight team in history, 4 astronauts begin their 2.5-year mission to the Red Planet. This will be the first time a human has gone beyond the Earth-Moon system, 250 million miles farther than any person has ever been. To counter the health problems of zero gravity and to fully acclimate the astronauts to Mars, the ship will deploy a weighted tether attached to the last stage of the spent rocket booster. By thrusting the ship into a rotational spin, the counterweight of the rocket will create centrifugal force and thus artificial gravity. The crew will be able to live with their feet planted firmly on the floor during their 6-month transit. But the HAB is not entirely alone on its journey. Just ahead of it is a second ERV, identical to the first. Launched just a few weeks prior to the HAB, it will prepare the way for a second human crew that will follow 2 years later. It can also function as a backup for the first mission if anything should go wrong. On the 6th month of the flight, the crew will gaze upon an alien world. This is the new frontier.
Oh, spectacular. Just spectacular.
After days in orbit and satisfied with the landing conditions, the crew will receive final word from Mission Control on Earth.
All systems are go for entry, descent, and landing. 3, 2, 1.
It will be a tense 40 minutes before people back on Earth get the signal from Mars and know if everything has gone well.
Okay, 75 feet. Car's looking good. Down a half. 6 forward. 60 seconds. Lights on. Forward. Forward. 40 feet down. 2.5. Big shadow. 4 forward. Drift into the right a little. 30 seconds. Forward. Contact light. Okay, engine stop.
We're seeing it on the LTP. We're on Mars, everybody.
For more than 500 days, the astronauts will live on Mars and embark on one of the greatest journeys of discovery in the history of science.